Information herein is for entertainment purposes only. It is not to be construed as legal, assay, business, valuation or investment advice. Please consult an appropriate professional before acting on any information contained herein. No copyright or trademark infringements are intended. Graphics, motion graphics and exemplifications in this presentation are not intended to precisely and perfectly illustrate the subject matter under discussion but are included only as generalizations. All rights reserved. This presentation may be privately or publicly exhibited from this YouTube channel for any educational purposes. No part of this program may be copied or reproduced. Magnetism, specifically ferromagnetism, is a force that attracts metals containing iron or steel. Screwdriver blades and steel shop tools will attach to household magnets as would paper clips, nails, nuts and bolts. Steel balls, like the one on your screen, also gravitate to household magnets. Shop tools, steel ball bearings, nuts and bolts are commonly said to be magnetic. This definition is not, however, suitable for discussing the hidden magnetic properties of elemental silver. Specifically, we must distinguish between three very different types of magnetism, namely ferromagnetism, diamagnetism, and paramagnetism, because each have entirely different properties and unique applications for screening silver. Understanding the differences between these three types of magnetism can help avoid costly selection or rejection errors. The pure silver ball on your screen is not attracted to a household magnet because silver does not have ferromagnetic properties. Let's now see how a neodymium magnet acts on some steel nails. Just like a household magnet, the neodymium magnet attracts the steel nails. We demonstrated ferromagnetic properties using a household magnet, screwdriver, steel ball and construction nails. Pure silver objects, however, behave quite differently when exposed to magnetic fields, especially powerful magnetic fields from neodymium magnets. Unlike steel objects, the silver ball is not attracted to the neodymium magnet. Quite the opposite, as the neodymium magnet closes in, it actually repels the silver ball. Neodymium magnets do not attract silver, but they can reveal an object's hidden diamagnetic or paramagnetic properties, which can be useful, but not conclusive, for screening silver. There are many ways to reveal silver's diamagnetic properties, and we now focus on two familiar methods, the magnetic scale and the silver slide. This section explores the difference between diamagnetic properties and paramagnetic properties, both of which can be useful in a preliminary screen for silver. Our first animation shows a neodymium magnet approaching a pure silver ball. The magnet pushes the silver orb forward as the distance between the two decreases. This forward push is registered as a slight increase in weight on a magnetic scale. Our next animation demonstrates a neodymium magnet's effect on an object with paramagnetic properties, such as tungsten. Note how the paramagnetic object is pulled toward the magnet. This pull is registered as a decrease in weight on a magnetic scale. Knowing the diamagnetic or paramagnetic properties can help detect counterfeit coins. If, for example, an American gold eagle exhibits paramagnetic properties, then it is likely a tungsten core counterfeit. You don't need to purchase a magnetic scale. You will find numerous instructions on the internet for do-it-yourself tests to help determine if an object has diamagnetic or paramagnetic properties. Neodymium magnets elicit the diamagnetic properties of silver, as well as that of many other objects. Testing for diamagnetic properties can be part of a comprehensive series of validation screenings for silver. The animation on your screen shows the simple conversion of a jeweler's scale to a magnetic scale. A scale sensitive to 0.000 grams is recommended for best results. A lightweight magnetic neutral pedestal elevates the silver ball to prevent the approaching magnet from creating false readings by interacting with the scale's internal components. To register the downward pressure from an approaching neodymium magnet, the combined weight of the scale and pedestal must be tared to zero. Once the magnet is lowered to within a millimeter of the silver ball, the weight on the scale increases, demonstrating that the object has diamagnetic properties. This does not confirm silver, because many other metals, and even non-metals, also exhibit diamagnetic properties. For this reason, you must perform additional tests to increase confidence in your conclusion. If the scale shows a negative number, then the object is not pure silver. The presence of tungsten, for example, registers a negative weight change, which is due to a property called paramagnetism. Magnetic scales may detect counterfeit tungsten-filled coins. That's because tungsten has paramagnetic properties that will register as a negative value on the scale. Considering that an object may contain an unknown combination of various metals, the results of any magnetic test must always be verified by further analysis. Magnetic properties can provide useful information about precious metals. In summary, ferromagnetic objects are not pure silver. Diamagnetic objects may or may not be pure silver, more tests are needed. Paramagnetic objects are not pure silver. Silver slide, also called a magnetic or neodymium slide, consists of an array of powerful neodymium magnets mounted on a sloping slab of wood or plastic. The magnet slide on your screen shows the reaction of a plastic poker chip when placed on the top segment of the slide and released. The chip slides down the slope very quickly, nearly at free fall speed. The rapid descent is because there are no forces to slow its momentum. We therefore conclude that the chip's properties are inconsistent with pure silver. Let's see how a counterfeit American Eagle made of steel reacts when placed on the same slide. Now that we have seen how a plastic object behaves on a magnetic slide, let's see what would happen if we replace the plastic chip with counterfeit American Eagle made of steel. Pure elemental silver does not have ferromagnetic properties, but a counterfeit steel American Eagle does. When placed on the slide, the steel eagle is immediately and forcefully attached to the slide. It might be difficult just to pry the counterfeit away. In this example, the slide has, indeed, identified the counterfeit. Since pure silver, and genuine American silver eagles, are not ferromagnetic, we can conclude that this steel eagle is not of pure elemental silver, and therefore a counterfeit. Silver slides do, however, have limitations even though they can detect ferromagnetic material. An object consisting of 50% silver and 50% iron or steel would still adhere to the slide in a manner similar to a pure steel round. Silver slides can be a helpful, and sometimes, as in the example of the American Eagle, a definitive screening tool. As commonly used, however, silver slides have other limitations, and one should perform additional tests to determine the presence of elemental silver. Ferromagnetic objects comprised of iron, steel and other metals, quickly attach to the first neodymium magnet. Pure silver does not have ferromagnetic, ordinary magnetic properties, and, therefore we will not adhere to magnets. Conclusion: this counterfeit silver eagle has ferromagnetic properties that are inconsistent with pure silver. Silver slides consist of an array of powerful neodymium magnets mounted on an angled piece of wood or plastic. The silver slide on your screen demonstrates how the effects of eddy currents created by a moving silver coin in a magnetic environment creates a braking effect as the object descends down the slide. Let's look at that again. This braking effect is sometimes incorrectly attributed to silver's diamagnetic properties, whereas, in fact, it is the eddy currents that cause the braking, slowing, effect. It would be wrong, however, to conclude that a coin slowed on the slide is indeed elemental silver. Relying solely on the silver slide test might convince you to buy worthless fakes. Be very cautious because non-silver metals, including pure copper or brass or silver-plated copper or brass, will also be slowed down. The presence of a braking effect is not conclusive proof of silver. Other factors that influence the silver slide test include the detailed composition of the metal or alloy of the object being tested, the strength of the magnets, and the angle of the slide. Magnetism as it relates to testing silver, is a fascinating but complex subject. For this discussion, however, the point to remember is that confirming silver based on the slowing effect on a magnetic slide can yield inconclusive, incorrect and unreliable results. Additional tests should be performed to conclude with a higher level of certainty that the material being tested is indeed elemental silver. German silver, sometimes called nickel silver, is not genuine elemental silver, but a silver-colored alloy generally comprised of copper, nickel, and zinc. To demonstrate why relying on the silver slide test can be tricky, let's see how this non-silver alloy exhibits braking properties similar to silver. Having no elemental silver, a typical German silver bar slides leisurely down the slide similar to a genuine silver bar. This demonstrates that the silver slide test is not a conclusive method to determine the elemental silver composition coins or rounds. Additional tests must be performed by a qualified professional to determine the true composition of any material. Precious metal buyers sometimes screen bulk lots of jewelry using a household or shop magnet, a process that can lead to erroneous rejections. In one actual example, a woman under financial pressure after a divorce took a beautiful pair of 14K gold, diamond and opal earrings to a pawn shop. She hoped to be able to sell the earrings to cover an income shortfall. The shop associate simply waved a magnet above the earrings which quickly attached to the magnet. Based on that one simple test, the shop wrongfully rejected a beautiful and expensive pair of earrings. Feeling dejected, she brought the earrings to me and relayed her experience with the magnet test. I duplicated the test but focused the magnet only on successively small parts of the earrings to localize the source of the magnetic attraction. This revealed that the magnetic attraction was limited to the area of the closing clasp, which likely had some steel components. While this subsequent test was not enough to confirm the presence of gold or diamonds, it did reveal that the shop's rejection was premature and additional tests should have been performed. Remember that gold or silver jewelry may have small embedded steel components such springs and pins that will attract to a magnet. Magnetic attraction is not conclusive evidence for rejecting jewelry. We are now nearing the conclusion of the section about precious metals and magnetism. Hopefully you have gained some new perspectives on testing gold, silver and jewelry using magnets. Subscribe now so you can be updated on future programs. Remember, this program is for entertainment purposes only. Always seek the advice of a competent professional before making valuation or assay decisions. And now, a brief moment for important closing information. The economies of the world are facing significant headwinds, a trend that will persist for decades. These challenges will force many individuals to resort to fraudulent, dishonest and criminal activities. Subscribe now and don't miss any of our future segments that detail fraud in the gold and silver markets. Future segments explore specific tricks and tactics used to deceive buyers, fleece jewelers, and even defraud coin and bullion dealers. We will also demonstrate the capabilities of various precious metal testing instruments and techniques to help prevent you from becoming a victim. Unsolicited material sent to this channel becomes the property of the owner and will not be returned. Please understand that we cannot answer questions, respond to requests, or offer opinions regarding any specific consumer issue or dispute. Our limited resources are sufficient only to focus on future video segments. Please like, share, subscribe and support.